for any relevant TSBs. After that, perform pinpoint tests of the fuel delivery system to find the exact cause. It's crucial to identify the root cause, not just replace a failed part. For example, a fuel pump failing due to tank debris means replacing the pump won't fix the underlying contamination. Lack of fuel causes power loss, hesitation, or surging. Excessive fuel from high pressure or leaking injectors causes flooding, misfires, or poor economy. Restrictions in air or exhaust also reduce power.
Fuel system DTCs can sometimes be misleading. How do you interpret them correctly to avoid misdiagnosis?
Fuel system DTCs usually identify a system problem, not a specific component, because the computer can no longer properly control the air-fuel mixture. For example, a lean exhaust code might be set because an oxygen sensor has failed and is reporting low voltage, making the computer think the mixture is lean when it could actually be running very rich. You need to consult the service manual for pinpoint tests, always considering what the computer sees to set the code.
What about the physical integrity of the fuel system components, like the tank and lines? What should technicians look for?
Inspect the fuel tank for leaks, road damage, corrosion, or loose mounting. Leaks in the tank or lines can cause gasoline odors. Nylon fuel pipes need to be checked for nicks, kinks, or melting. It's important not to force sharp bends in nylon lines as they can restrict flow. Also, always obtain a fuel sample to check for contaminants or excessive alcohol content.
Fuel delivery depends on both pressure and volume. How are these tested for fuel pumps, and what do the results indicate?
You perform both pressure and volume tests. Proper pressure is necessary, but adequate volume, typically 1 pint in 30 seconds, is equally vital. Low pressure can be due to a restricted line or filter, a defective pump, or poor electrical supply. High pressure usually points to a bad fuel pressure regulator or restricted return line. Fuel pressure leak-down tests after the engine is off can indicate a bad pump check valve, regulator, or leaking injectors. Fuel filters should be replaced at specified intervals or more frequently if fuel quality is poor.
How are electric fuel pumps controlled, and what are common electrical problems that can occur within their control circuits?
Most electric fuel pumps are controlled by the computer via a relay. The relay energizes the relay for a few seconds to prime the system when the key is first turned on, then turns it off if the engine doesn't start. Once the engine is running and an RPM signal is received, the relay stays energized. Many vehicles also have an inertia switch that opens the circuit in an accident. On some imports, the control circuit runs through airflow meter contacts. Diagnosing problems requires obtaining wiring schematics to understand the specific control circuit.
The fuel pressure regulator is crucial for maintaining correct fuel delivery. How is it tested, and what can go wrong?
You can test for diaphragm leakage by removing the vacuum hose with the engine running and checking for fuel. Fuel pressure should drop by about 10 psi when the vacuum line is reconnected. Excessive pressure means a stuck closed regulator or restricted return line. Low pressure could be a weak pump, restricted filter, or a stuck open regulator. For a pressure leak down test, clamping the return line helps isolate if the regulator is leaking. If that doesn't stop the drop, then the pump or injectors are suspect. Never clamp plastic fuel lines directly.
Throttle body cleaning can resolve many drivability issues. What's the proper procedure, especially considering other components?
Gum and carbon deposits around the throttle can cause rough idle and stalling. Initial cleaning can be done with throttle body cleaner spray. If that's insufficient, the throttle body must be removed, disassembled, and cleaned in an approved solution. Critical point: the throttle position sensor, idle air control, fuel injector pressure regulator, and seals must be removed before placing it in cleaner for MFI or SFI systems, though TPS and IEC are T for TBI. After cleaning, adjustments for closed throttle position and TPS voltage might be necessary, always following the service manual.
Fuel injectors are precise. How do you test their function and cleanliness?
An injector balance test monitors fuel pressure as each injector is fired. A significant pressure drop difference between cylinders, typically more than 1.5 psi, indicates a problem like a plugged, restricted, or leaking injector. A lap scope can also assess their electrical integrity by observing voltage and current waveforms. When cleaning injectors, the vehicle's fuel pump must be disabled and the fuel return line plugged to prevent cleaner from entering the fuel tank. Afterward, adaptive memory often needs to be reset and spray patterns checked if removed.
Air filters are simple components, but vital to engine longevity and performance. What's important to remember about them?
If a vehicle operates in dusty conditions, the air filter needs more frequent replacement. A damaged filter can lead to increased wear on cylinder walls and piston rings. A restricted filter reduces airflow to the intake, which in turn increases fuel consumption. It's a small part that has a big impact.
Leaks in the intake or vacuum system can cause a host of problems. How do technicians effectively locate them?
Intake manifold vacuum leaks can cause rough idle, stalling, or incorrect idle speeds, leading to fuel tremors. Technicians can use propane, flowing it around suspected areas, and if the idle changes, it's a leak. A smoke machine is also very effective, as they can locate leaks without the engine running, including those in vacuum accessories. On mass airflow-equipped engines, unmetered air entering after the sensor causes lean conditions and performance complaints.
Many fuel system vacuum and electrical components interact. What's the general approach to inspecting and testing these?
This covers items like the fuel pressure regulator, vacuum-operated throttle positioners, fuel pump relays, and inertia switches. Visual inspection is crucial for damaged vacuum lines and proper routing. All electrical connections need to be checked for terminal seating, damage, or corrosion. Basic electrical testing with a test light and DMM helps identify problems. Always consult the service manual for specific components and test procedures.
The exhaust system is extensive from the manifold to the tailpipe. What's the overall inspection process?
You typically remove the exhaust pipe bolts at the manifold flange, disconnect any O2 sensors, and then remove the manifold itself. Clean mating surfaces thoroughly and check the manifold for warping or cracks, then follow the rest of the system, ensuring all hangers are present and correctly installed and that pipes, mufflers, and resonators are securely connected and gas tight. Any part in tension should be realigned.
Exhaust restrictions can severely impact engine performance. How do you test for them effectively?
Excessive exhaust bag pressure, often from a restricted catalytic converter or muffler, reduces engine power and top speed. A low-range pressure gauge can be connected into the exhaust system, typically through an O2 sensor hole. Back pressure should be less than 3 psi maximum at 2500 RPM. Another method is to measure intake manifold vacuum. Normal vacuum at idle is 16 to 21 inches of mercury. If it drops very low or to zero when revved, it indicates a restriction.
Turbochargers and superchargers boost performance but add complexity. How do you diagnose issues with these forced induction systems?
Both increase air pressure to the engine. A turbocharger is exhaust-driven and uses a wastegate to control boost, while a supercharger is crankshaft-driven. To diagnose problems, you measure boost pressure with a gauge connected to the intake manifold during a road test under various speed and load conditions. It's important to remember that these units are generally non-serviceable. If defective, they are replaced. Only their control circuits are typically serviced.
Moving to emissions control systems, the positive crankcase ventilation or PCV system seems deceptively simple, but can cause various issues if it malfunctions.
If the PCV valve is stuck open on a carbureted engine, it causes a lean mixture and rough idle. On a fuel-injected engine, it can cause a high idle speed. If the valve or hose is restricted, excessive crankcase pressure forces blow-by gases into the air cleaner, often with oil accumulation. If there's excessive blow-by, it points to internal engine wear. Testing involves listening for the valve rattle or specific blow tests and vacuum checks. Diagnostic recommendations can vary by manufacturer.
The exhaust gas recirculation, or EGR system, is critical for reducing NOx emissions. What are the common problems and how do they affect the engine?
If the EGR valve stays open at idle or low engine speed, it can cause rough idle, stalling, or hesitation. If it doesn't open when commanded, it leads to engine detonation and increased NOx emissions because combustion chamber temperatures rise above 2,500 degrees Fahrenheit, allowing nitrogen and oxygen to combine. A stuck open valve creates a density misfire condition, increasing hydrocarbon emissions.
Secondary air injection and catalytic converters are key parts of the exhaust treatment